Hi guys, so today we'll be making a slingshot straw rocket. So the materials you'll need for this are cardstock, which is like a strong paper, a wider straw, specifically one with a 1/4 inch diameter, masking tape, an eraser tip, a popsicle stick, a brass paper fastener, a rubber band, preferably a big one, but you can also use smaller one or tie two small ones together. And finally, scissors. Get to it, please. So first, you fit the eraser tip onto the end of the straw. Then, grab your metal fastener and bend it a little and attach it just below the eraser with 2 pieces of tape. Now, cut 3 triangular shapes out of the cardstock to act as a fin for the rocket. Now, attach the fin like so. This ensures the fin are in place and secure. Now, to make the slingshot, get your popsicle stick and a piece of masking tape. Attach the tape to the end of the stick with about half of the tape left over. With the leftover tape, put the rubber band on it and fold the tape over to secure the rubber band like this. To launch your rocket, hold the popsicle stick straight up and down in one hand and notch the rocket on the metal fastener like this.
So what's the science behind the rocket? Well, in the gratifying project of the slingshot straw rockets, the stretch of the rubber band creates potential energy, while the release of the rubber band produces kinetic energy. The 3 concepts to be considered are drag, momentum, and stability. When the rocket is launched, the surrounding is pushing against all of the exposed surfaces and slowing it down, which is drag. To overcome that drag, more momentum should be generated. Momentum is mass multiplied by velocity, and is also the force that keeps an object going in the direction that's already moving in. More mass on the rocket generates more momentum and helps pull the rocket to overcome drag. Stability takes place through the fins because it pushes the back of the rocket back into alignment until it's experiencing the minimum amount of drag that it can. This is what keeps the rocket on course. This is why it's important to attach the fins on straight. If they are even a little bit crooked, that exposes it to the oncoming air, which will generate drag and slow the rocket down.